Good morning, everyone. Good afternoon, everyone. Hope everyone is doing fine and enjoying the weekend. Thanks, everyone, for joining us today. If you all can hear me, just give me a confirmation and we will quickly get started. I could see a lot of people are repeatedly joining our webinars and our sessions. So thanks everyone for that. And Parna is here. Parna is helping us with question and answer. So please put your questions into chat. And we have impressive lineup of guests. I could see a lot of familiar name. I see some of my old acquaintance, and we see a lot of new people also. So welcome everyone. And we hope we would be giving you the best learning experience for the next 2 hours. And we are always open for input. So any suggestions, any feedback you have, anything we can do differently to make your learning better, just let us know. If you check our schedule, we have like the program schedule we have last week, which is not filled in right now. We are looking for suggestions if there are any topic you want us to cover, and obviously if we know about those things, we will be happy to cover that. So give a suggestion. Last week for technical track is open in terms of security track also, as well as foundational. So anything which you feel we can include, which will be from which will help broader audience, we would be happy to include that. Thank you. Let me add Carl quickly to call. Carl is also with us. So, hi, Carl. Carl has come up again. So, he is helping us, and thank you so much. He would talk about the key encryption. It will talk about the concept of KMS, interesting topic and confusing to me. So, I'm listening to that. I'm looking to that. I want to learn from that too. And we have Parna, and as always, behind the scene, helping us with all the management of this. Thank you. So I'll quickly get started and then let me know if you see the screen. I hope everyone can see the screen I'm sharing. I'm on batch number 04, week number 5. Yesterday in the LinkedIn schedule, I messed it up a little bit, but hopefully everything is okay now. Everyone is finding it, was able to come up, and let's quickly get started. Let's get started, Omkar. Thank you. Let me put myself on the backside and let me make the screen bigger so that you could focus more on the content part. So we are on batch number 4, week number 5, and what we are going to discuss today, we would have 40 minutes of fundamental track, which I'll take care, encryption. Then we would have Carl, who would help us with specialist track and network in security, which is encryption services in AWS. There are plethora of services related to security, and encryption ties with everything. So he would help us. And then we have Jonathan showing up Jonathan is an account manager and he would help us in understanding how account manager work with customers on day-to-day basis. And if time permits, I would also ask him that he interacts a lot with solution architects. So we will try to understand like what kind of expertise he expect into a solution architect, or what qualities would make a solution architect successful more than the other. So we will discuss that. So Jonathan would be coming up also on the stage when the time is there. Let's start by encryption basics first. Very basics, fundamental. Some of them I have already covered in my previous session, but I wanted to bring everyone on the same page, and that's why I'm talking about encryption basis. I want to start with a question. What you are seeing on a screen is something looks like some leather strip and some wooden pack behind it. Can anyone tell me what this is? What is happening here? What is this picture depicting? Obviously, I'll explain it, but I want to understand from you what is actually happening here. And context is already encryption, so probably you have guessed a little bit on that, that it has something to do with encryption. But if anyone can give me a little more idea, like what this is Cital, Sebastina, make exactly encrypted code, Devesh, exactly. This is the same thing. Yep. This is not the best kind of cipher or best type of encryption, but this is what used to be used by Greek generals when they were trying to ensure that the messages were passed between the uh, military units, and nobody should be looking into that message and nobody should be able to understand what is happening. Should we attack tomorrow, or should we retreat, or should we defend that position? That all messages were encrypted. So this was a very early form of encryption, not as sophisticated as is it now, but yeah, it was still working well at that time. What I'm seeing here, I'm trying to see two things here. First thing, this is obviously a title as you mentioned, and I would include a link for the Wikipedia so you could read a little bit more on the history. And then what we have here, this leather strip contains the encrypted message. So whatever I have to send to someone, I would put it down into a letter strip in this format, and then I have a key by which I am able to open that message, and afterwards only I am able to read it. If I do not have the key, or if I have a different key, obviously if the message may not be as visible as possible, I may still be able to try to figure it out. But this is how they have initially created encryption. So there is a key and there is an encrypted message. So hopefully this is you have seen so far, and let's keep on moving forward. Now I want to use analogy to explain encryption, a very simple one. Probably some of you already know about it. We all use debit and credit card, right? So that debit and credit card is something we use all the day, and to protect our account there, what we need a pin number associated with that. So we have this pin number. Let's say pin number is 4582. Now, bank, when they send us this debit card, credit card, and PIN number, they also take care of security. They will not be sending the both things together into one single postal mail or a courier. They would ensure that they use one method for delivering PIN and another method or another courier service for delivering the card, trying to keep things separate so that not a single person would have hands on it and would be able to misuse it. So that is a common tactic followed by banks when they deliver these messages to you. Now, apart from that, if I have to use this credit card or debit card, probably it is not the only credit or debit card I have. And if I have too many debit credit card, then remembering the PIN can become a little bit challenging. One option, the easiest option I could think of, is to write down the key on the card itself. That is, I'm saying easiest option. So if I've seen some people do it. They have a sticker and they put a sticker or they write down the key card number on the card itself, which is not at all safe. Somebody could misuse that, and we may not want to fall victim to that. But that is still easiest method is that I write down 4582 on the card number, and anytime I take out my card, I know the PIN number. I don't have to remember it. So this is the most convenient, but it is not at all secure way. But this is what it is. What can I do in this case? I could say, let me encrypt this number. My intention is to protect 4582. What I could do here, I may use a simple algorithm which is plus one and minus one, and this plus one minus one is put on this pin number. What I do, I take the 4582 as a plain text, now using a keyword here, plain text, and I then apply the key on that. I add first number in one digit, remove one number from second digit, plus one minus one plus one minus one, and what I get now, I get a different number. That different number is what we call a cipher text. It is not a full encryption, but it is a obfuscation or alteration of the digit which I did, and based on that, this 5491 has become a new number. That new number I would be storing on the card itself. So even if somebody is able to find the card, has 5491 as a number, still they won't be able to utilize that card. Now, some other method sometimes people follow for encryption of this data, or that is like a like repositioning the digits. So if it is 4582, what they could say, okay, let me write it down as 2854. So when I would use this, I would reuse it from this manner. Or if I want to be a little more creative, I could say, let's make changes like this only, right? So I change 4 to 5, so it becomes 5 4. I change 2 to 8, so it becomes 2 8. Now, what I did, I just reshuffled the digit, but I'm still able to hide the text. Now, if I have this, then maybe I still can have factorial 4 combinations, and through that I have 2 to the power something, and I would be able to get these numbers sorted, right? So it may not be very safe, but if I have done it completely changed to 5491, then it is making the life little difficult for the hacker or whoever is trying to get into my information. So what I have here is a cipher text which is 5491. All right. Hope everyone is following along. Now, if I have to decrypt this message, decrypt and use my card, what I do, I take this 5491 and then reverse the key. This is the easiest format of encryption. -1 +1 -1 +1. Whatever I applied, I reverse the key, and what I get now is 4582, and that 4582 I could use with my card, and I should be able to access my account. Let's dissect what is happening here. If we look at it, the key we used is called +1 and -1. Within that key, we have two component. First component is called algorithm. So I decided to use plus and minus as an algorithm. You may have decided to use plus plus as an algorithm. You may have decided to use minus minus as algorithm. You may have decided plus and into as algorithm. It is up to you. Now, obviously, depending on what algorithm you are using, it may take more time to process or it may take less time to process. Like plus operations would be easier, but what if I have decided to have a into and a divide operation? Obviously, it will take more time to decrypt that, and it may require more processing power for me. So as strong the algorithm is, I would be able to protect my data better, but it would have a decremental effect on my processing power, and it may require little more time for me to decipher that text, but still possible. So what you are seeing here is a plus and minus, that is the algorithm. Now algorithm is good, but with algorithm we have also need to provide something called a value. That is what we refer as key material. So key material is what we have created in real world. It is a very random prime number generated, and through that your key material is created. You may create some randomness, and through that randomness you would be using key material applied with algorithm. We will talk about some algorithm as we move forward, and that would give me the encryption and decryption mechanism. Now, if I'm using the same key material for all of my card, and if somebody, let's say I have 10 card and all these 10 card I use +1 -1 as algorithm, then it is a complicated thing. Somebody should be able to decipher it. So what I say, let me make it a little complicated. Let me select the second last digit of every card and use that as my key material. So I'm still using plus, still using minus, but this card will be +3 and -3. Another card which was 2152, in that case it would be +5 and -5. So what I did here, I created more combination possible, ensuring that nobody is able to figure out my all card number. If they're able to figure out one, we randomize the outcome of whatever is possible, right? I hope this is clear. But now your method may not work. If my card number was 5002 and now I say, hey, I would use +0 as my key, then +0 -0, even if I use it, I have actually stored the same number, which is a little risky. So it depends. Like in this case, +0 and -0 may not make sense, and I may have to figure out a little bit different method for it, right? I hope this is clear. Let's keep moving forward. Let's see what can be done further to enhance it. So we can use two type of encryption, which are a very common one, which is called symmetric and asymmetric encryption. Symmetric encryption is what we'll discuss in a minute, and asymmetric, but these are the two most common type of encryption. Depending on your use case, you would use both probably, or you would use one of them. In our computing world or in internet, we use most of them. We use both in combination. We use symmetric as well as asymmetric encryption also. Symmetric encryption is pretty simple. It says I would use the same key. In your house, you have a key and lock. That is a symmetric encryption. That same lock we use to lock the house, same key, and same key we use to open that lock, and that is a symmetric encryption what we have. Asymmetric is little different. Asymmetric says I would be using two different keys. One would be used for encryption and another would be used for decryption. So you lock by one number and you open by another number. That is called asymmetric. I'll go into little more technical details of these types of encryption to give you a little more context on that. So in symmetric key, we encrypt and decrypt using the single key. That is what we do. But in asymmetric, we encrypt and decrypt are accomplished using two distinct keys, that is referred as public key and private key. And sometimes this method of encryption is called PKI, public key infrastructure. As the name says, public key is for everyone. Private key is only for me. I give a simple example, not exactly same. Like let's say I give you my email address at ashish@analogiescloud.com, right? This is my public key. I would be happy to share this with anyone, but I won't be sharing the password associated with it. That is my private key, and only I would be knowing that. You can all send me email, but only I with the private key is able to, or me, I am only able to read that information. So this is a two-piece information. I need the public key and I need a private key, which is my password, which is only been available to me. We will not be sending anything to this specific environment. Can automatic lock compare to asymmetric? Matthew, I would say automatic lock, you are not using a different key all time. So it is a form of encryption because there is a different key, but automatic is not is automatically locked, right? So you do not put a code to open it. Like if it is a spy craft, like talking about the Cold War time and all, that spies used to do a lot of encryption on that. SSH key is the exact example, Naman. That is good example of that. We will discuss some more examples when we talk about. But the simplest example would be when you are using your web browser and you are connecting to HTTPS website. That time we are utilizing that public private key mechanism. So this key is available for anyone to download, which is a public key. But when I have encrypted something using it, only the private key can be shared. Same like an email address I shared with you, you can all send me email, but only I would be able to use the password to remove it. All right, good. So that is symmetric asymmetric encryption. Due to simplicity, it is faster. Same key, no complication. So that is very, very fast. It is not very complicated on your CPU to process. That is the simplest form of encryption. And asymmetric is complex because there is a key exchange happening and then tunnel is formed and then encryption happen, then trust verification happen. It is slower and require more processing power. Compare the same example. I used plus or minus as algorithm, and then I use this and the factorial and maybe divide by pi and get the value. I could implement any complex mathematical formula. Obviously, it would require more processing power for me. Okay. Symmetric keys are smaller in key length. So smaller in the sense they may have 128-bit, 256 bits for doing the key generation, whereas asymmetric keys are mostly longer. And if I'm just taking an example of a key called RSA, it is 2048 bits. And obviously there are smaller numbers also. Recommendation is 2048 bits. When you get time, search for what is the full form of RSA. It is a homework for you. Check for that. Interesting thing. So this is what a longer key length for asymmetric encryption, and then we can have use of symmetric key for bulk encryption, right? So bulk encryption is what is where we will use symmetric key. If you are locking the whole house, You won't be creating a lot of complicated stuff. Probably there would be a lock, and through that lock you are locking it. So it is typically used for bulk data encryption. On the other hand, in your house, if you have a safe in which you are keeping your important document, obviously there would be a different mechanism, and this would be more sophisticated than a traditional lock. So asymmetric key, it is used with smaller data transaction. Primarily, it is used for authentication and to create a secure communication channel before the actual data transfer happens. Like in real life, sometime old process was two spy want to exchange information. They would first talk about a code word. When the code word is verified, then they can start communicating. That is the exact same thing. So asymmetric is used for smaller data transmission. Maybe it is to authenticate, and once they trust each other, then they would start sending information with probably traditional symmetric encryption. So that is what asymmetric key is all about. All right. Keep your questions coming. If any doubts, any confusions, we would be happy to answer them. Talking about symmetric key, ciphertext size is not much different from original plain text. So if let's say this plain text I had was 2 kilobyte, I encrypted it. Maybe what I get as an output as encrypted, it would be somewhat around 2 KB, not huge amount of difference will be there in the size. But in asymmetric, as we are doing a lot of complicated stuff, ciphertext is bigger than the plain text. Obviously, that won't mean that transmitting it will take time, storing it may take time. So this may consume little bit more bandwidth and more space because its output is coming a little bit more higher than your traditional symmetric key. Okay, then symmetric keys is what we use only for encryption, but they are not used for signature because signature verification require a third party to verify is it a valid signature or not, and that's why we use a PKI asymmetric. So asymmetric keys are preferred for digital signature as well as both can be used for encryption and decryption, but most of the time you would be seeing symmetric key being used for encryption. Asymmetric is used first to authenticate someone and maybe to verify the trust, and once this is done, then all the transfer may happen with the symmetric key encryption. So that's how we use it. So asymmetric key is used for transaction process. Yes, exactly. So whenever, see, I won't say always, but whenever you are doing, let's say, a credit card purchase, now that data is very small, right? So whenever you're doing that, that is happening through your asymmetric key. I purchased something, my information went to bank, SSL certificate. Yes, exactly. SSL certificate would be using asymmetric key first time to create a tunnel, to create a secure channel. And once they have established the trust, once they have created an encryption method, probably they would come up with something called a session key, and through that session key would start transferring the data. So for the first time, I may perform all the checks and verification, and once the checks and verifications are done, maybe I would fall back to my symmetric encryption because it is much easier to process, much easier to follow along. So that depends, but SSL is a good example. When you log into a EC2 machine using a key pair through SSH, that is a good example. These are all the option where asymmetric keys are used. So if it is a smaller amount of data, asymmetric would make sense. If it's a huge amount of data, let's say I'm locking my hard disk or encrypting my hard disk using BitLocker, or I'm using some other mechanism of encryption on my server, that will probably a symmetric key. Okay, good. Last thing here, algorithms. Algorithms are basically mathematical formula. So these mathematical formulas are different for symmetric as well as different for asymmetric. So if you look here, these are old one, DES, then RS, RC4, 3-dias, AES. AES is a very common one nowadays, which is used in most of the time. And then ChaCha 20, these are all some symmetric key encryptions. And then we have asymmetric. In asymmetric, you will find RSA being used most. Diffie-Hellman is very commonly used. Then elliptical curve Diffie-Hellman. These are all available options which you could have used for encryption. Now you can decide in some places, like when you're establishing a connection, that time you could establish that what is the key mechanism, what algorithm I'm using, and depending on that, a channel would be formed, and then your data transfer would happen on top of it. All right. So I hope everyone is following along. Symmetric, asymmetric, and these slides would be available in PDF format on our website. So you should have no problem in accessing this content afterward too. Let's keep moving forward. Little bit of background information that how these keys are generated actually. So when these keys has to be generated, there is a huge random number generated first. Now, if you generate key using some software, they would say, please move your mouse. And based on that mouse movement, they would calculate something. That is a random number they are generating. In some algorithm, there would be a complicated curve like Diffie-Hellman elliptical curve that controls that, okay, when is a line, where is a tangent, what angle they are cross-sectioning it. And then based on that, they create something called a mathematical formula. And so this is what my elliptical curve algorithm is. That is what you could use. So that depends. So we take a large random number. That large random number goes into a key generation program, and through that key generation program, what we get at the end is what we get the keys. That's how your encryption process is generating the key. And every time you input a new random number, obviously the output of that would be obviously different, and that's how we can get the different key all the time. But if you look at it, it is basically a mathematical formula behind the scene. It is so complicated. And that's why a lot of people fear that when these quantum computers will be there, quantum computers would be able to perform all the calculation and may be able to decipher the text which we have just encrypted as of now, because right now our computing power is there. Like, let's say you used a X algorithm, maybe if you randomly try, it may take, let's say, 300 years to decrypt that message on a brute force attack kind of a thing. In quantum computers, that number may be much lesser. So that's why there is a lot of fear right now on what method we could use to bypass the quantum mechanism which is there. How does barcode works via scanner? It is also kind of encrypted pattern which get decrypted by barcode scanner. It is a little different story. It is not purely encrypted. It's not that much encrypted. It is just a way of representing information in a way that a machine can understand. If you look at machine, we say one and zeros. So in machine, I could read one line which is a thinner and another line which is thicker. So that is much easier. So it is a representation, they wish. It doesn't mean it is highly encrypted information. It is just a representation which is easy for devices to read in supermarket or any other places. That's what we mean by barcode. So it is a pattern, I would say, rather than an encryption. Okay. All right. Next thing, how encryption works in AWS. Obviously, the detail would be covered by Carl, but I'm just trying to give you some context that where all encryption services may be working in AWS. So let's talk about it. So we talk about encryption in transit and encryption at rest. Both type of encryption is what we use. Depending on what your use case are, you would use only one, or I would say probably you would be using two. So let's say this is your AWS cloud, and in that cloud, you want to host your application. So there is an entry point for any application. There would be some front end which will be doing the processing, or front end or processing, whatever you call it. And then we use storage to keep our data. Now, what could be my front end or entry point services? My entry point services could be load balancer. It could be API gateway. It could be CloudFront. These are the common ones we use, but you could have your EC2 instance directly as an entry point. And when it comes to processing or compute, that time we use EC2, container, Lambda, or any other services of our choice. And when it comes to storage, again, a huge number of services available like S3, Glacier, FSX, EFS, DynamoDB databases. These are all possible combination for keeping my data in that. And now if I'm a user, I would be connecting like this. I won't be accessing your storage tier directly. I would be coming first time to your front end. That is the entry point. So when I am connecting to entry point, that is where encryption and transit is happening. When I have to establish a session, let's say to a API gateway, what happens that in between API gateway and me, a tunnel is formed, a secure communication channel is formed, and on that channel, all these communication happen. So this is what we mean by encryption in transit. Idea of encryption in transit is if somebody, a hacker, is in between, they capture my packet and they are trying to decipher information from that. That should not happen, because what we did, we have encrypted message. So this API gateway would have a public key, would have a private key. Let me write private key this side. So there is a private key here. And what this API gateway is doing, that as soon as I say, okay, I want to communicate with you API gateway, my public key is shared here. So this is public key, and I would encrypt all the data I want to send using this public key. encrypted data of this public key can only be decrypted by my private key. So even if it is being accessed by someone else or it goes into other services, they won't be able to decrypt it because it has been encrypted by the public key generated, and they are generated into key pair, and they are related but still completely different, right? They are generated together but they are still different. All right, so this is what we mean by encryption in transit, and that will ensure that we have created all the encryption channel for communication. And to implement this, we use SSL or TLS certificate. SSL stand for secure socket layer, TLS stand for transport layer security. So this is a mechanism to protect your data in transit, and for that, the service we use is called AWS Certificate Manager. So certificate manager as a service is going to help you in generating certificate. Obviously, this is not mandatory. You could get your certificate from any third parties and bring it back into AWS, and you should be able to then use those certificate along with your services. The benefit certificate manager is giving you that it is integrated already. So I do not have to do a lot of complication. Through this, I could generate new certificate, and through those certificate, I should be able to apply certificate on my front ending services like API gateway, CloudFront, and load balancer, and maybe some other services. So that is what is a encryption in transit. When I'm talking about services at storage, that is where encryption at rest happens. Think of encryption at rest as, let's say this is a storage bucket, could be S3 or whatever. Now I am sending an object here. This is my object. Now, this object, when I say it is encrypted at rest, so when this object is entering into Amazon S3 and being stored in some shape or form, ones and zeros, then it is in a format which is not accessible without it. But so the idea is, if let's say this was a hard disk in AWS data center, somebody broke in the data center, bought this hard disk or stole this hard disk, take it to their home, connect to their desktop or server PC, and I'm trying to decrypt from that. It is not actually happening. Why? Because it has already been encrypted at the rest, right? So when I say encrypted at rest means in its a raw format, when it is hitting the disk or ones and zero format, then it is all encrypted. So nobody can access this information required. At what level will encryption be responsible of client cloud provider? It depends on the service to service. So if I give you an example, so when our network communication happens between our regions, so if a region to region, region 1 and region 2, we are doing a communication, let's say you are transferring your Amazon S3 replication or you are performing a DynamoDB global table replication, that is all encrypted. So all the communication on AWS global network is regional, sorry, it is encrypted by default. All of that communication is always encrypted by AWS. So that is a cloud provider. Now I am storing an object into S3. Should I encrypt it or not? That is my decision, right? I may say this object is not worth protection. I may decide not to use it. I am creating a EBS volume. I may say I want to protect it or not. Do I want to encrypt it or not? I am creating a EFS share. Do I have to encrypt it or not? So that becomes client responsibility. Put it like that: any data which you are generating, it is your responsibility to protect it. Some services have default encryption, like DynamoDB, there is a default encryption. Now S3 has a default encryption. So cloud providers are trying their best to provide as much encryption as it, but at the end, it is a client's responsibility to take care of their data, internal communication of services, or when you are talking to a AWS endpoint, like you are talking to API gateway or ELB or someone, that would be responsibility of service provider. So like some services, if I look at Amazon S3, we provide you an HTTP endpoint to communicate to, and we provide you an HTTPS endpoint to communicate to. So you decide where I want to send my signal to. You could also configure in S3 that, hey, I would only accept requests when they come on HTTPS. If HTTP is used, I won't be going ahead and deploying anything at all on that. So that's how we will see. S3 is encrypted by default. Yes, now it is there. It has been recently announced, maybe a couple of months back, that S3 is by default encrypted now. Right. So new buckets will be encrypted automatically. So encryption at rest, hopefully this thing is clear. Encryption at rest is implemented by KMS, which Carl is going to talk about today. I'll quickly explain some basic stuff on that. So KMS will be helping me with generation of encryption key, and those encryption key would be used by the services as we see here. So that's how our services would get encryption. Let's talk a little bit more on the certificate manager. Certificate Manager, or ACM in short form as we call it, this is a service which is responsible for generation of certificate, provision, manage and deploy. Provision is that I have to get the certificate created first, right? Like if you go to an AWS exam, what do? You go ahead to in this exam, and that exam center, or even if it is online, they will ask you to present a proof of ID. You have to provide them with a government ID proof, and that will say, okay, you are a valid person, and that is what we somebody has provisioned it for you. When maybe your birth certificate was there, and then you got a passport based on that, or maybe you have a driving license, or maybe you have an electoral card, whatever, that is your provision certificate, and that you present to someone as they trust the provider. So they trust government, and that's why they trust you also, because you have a valid certificate provided by a trusted entity, which is government here. So how much we trust government, it is a different story, out of the question. But yeah, this is what happens behind the scene as we are discussing. So we easily provision, manage, and deploy public and private SSL TLS certificate using Certificate Manager. We provision, manage, and renew certificate. So that is the best option, I would say, with my Certificate Manager. If you have worked in this field of certificate management, most of the time you would see administrator maintaining Excel sheets, and in that Excel sheet they would have certification detail, who was the provider, where it is being used, what is the expiry date, and they have to keep on going to this sheet and manually go on rotation, manually go for renewal, which is complicated, which may come up with a security loophole, or which may create downtime. Certificate Manager helps you with that. And now once this is Certificate Manager, it just becomes a message in my inbox that hey, your certificate was expiring and we have actually renewed it. So that is what easy option with this is, right? So that's what we use it. Now, is network traffic within AWS data centers encrypted? I'm not sure on that, Rupa. We do not have any official confirmation on that, but I would still say yes, probably, but I'm not committing officially anything on here, because that information, at least I'm not aware if it is publicly shared. I'm sure on the backbone, all the communication which happens is protected by encryption, but what happens within data center, my guess is should be, because we are following a lot of compliances, but I still do not have an official stand there. This can also be used for private security authority, certificate authority. So if you internally you want to use a certificate, that can happen. Like if I give you an example, so within your company you may have given somebody some certificates, right? That is like he or she worked best, or best team member of the month, or best employee of the year, or whatever. But that validity of that certificate is within only that company. But if you got a certificate, let's say from a government institution or a publicly renowned body like a Guinness Book of Record, that is a public recognition, everyone knows Guinness Book, so they would be trusting the certificate given by them. But should they be, like you see on LinkedIn, people write lots of stuff about themselves, this is self proclamation, so that is a private certificate they have given to you. Same way, Certificate Manager can be set up for your internal network to decide and give you the certificate if the need be, so that is possible. This is also free for ACM integrated services, and I will show you the list of the services which are available, and that is what save me money also. And if you want to also import third party certificates there, that should not be a problem. We could bring it that there also, shouldn't be an issue. So Certificate Manager support a growing number of AWS services, and if I try to access this information here, this is what my services which are integrated with Certificate Manager. So ELB, CloudFront, then Cognito, Elastic Beanstalk, App Runner, API Gateway, Nitro, CloudFormation, all of them are supported by Certificate Manager. So I hope this thing is clear and you got a little better idea on what a Certificate Manager as a service is. We'll be talking more on the KMS side. Let me quickly set context for the next section. So KMS is a service which we will be using for encryption as well as digital signing. So in AWS, The service is a fully managed service. It has auditing built in, so I would be able to know who used my key and in what context they use the key for encryption or decryption. Obviously, it is compliant with various standards like PCI, HIPAA, FIPS compliances. These are all there, and it supports something called a custom key store. So you could bring in your custom hardware modules, or you could use custom modules, and through that you could generate key. What KMS service uses behind the scene, it uses a hardware called HSM, which is used to store key material on the device. And what is HSM? This word is used again and again, hardware security module. So HSM is a physical device. If you look at it, it looks physically like this server. So this is a HSM device. It is a physical device which has tamper-proof architecture, maybe coming in different shapes and form. And in some places, it could be an internal device too. And through that, we are able to perform this key generation, encryption, storage of the key. This is not designed for huge storage. This is designed for all the specific key storage only. It is not designed to store huge amount of data, but it is designed to tamper proofly store your keys which are being generated for you. So that is what is called HSM as a service, and Carl would be talking more on that. Carl will also be talking about envelope encryption. So I just want to give a little context which will be further explained into the next section. So when I talk about a house key, so let's say this is my house key and I have to protect that key, but I do not want to carry key with me. Let's say there is a shared flat and I have to share key with my room partner or with my partner, whoever. So what I could do here, I could do this. Not very safe. That will be creating problem for me. So if I do this, I have kept my key, which is near to the door, but anyone can pick it up and that would create complication. So that is where envelope encryption can be of use to you. What we could do, we could get a device like this, which is called your lock safe. And what happens now? Due to this, I have fixed this lock safe on my house front. And what I do, I first lock my house. So that is my key one, and that key one I store within this box, and then I again scramble the numbers. So there is another layer of protection added. So now actual data is inside the house. That is my data which I am trying to protect. First I encrypted it using this house key, and that house key is further protected by my key safe on which there is another number. So this is what we refer as envelope encryption. We have enveloped the key. What we do when we write a letter, we don't want everyone to read what is written inside, so we put a envelope on top of it. Same way, this was my key. I wanted it to be protected by everyone else, so I have kept it here, and then I have added one more key on top. That is what is called envelope encryption. That is what Carl would be talking about into the next section. So I hope everyone has followed along and understood some basic concept. We would expand on the implementation aspect on the next section. So let's take a quick 5 minute break, and then we would come back and we'll discuss more interesting stuff. If everyone hopefully is enjoying, please let us know if there are any questions, any suggestions. We would be taking 5 minutes break and coming back again. Thanks everyone. Talk to you in 5. All right, everyone, welcome back. If you are back, then let me know if you remember this movie. Anyone? There is a key. So I thought like it would be not out of the context to talk about that person. Anyone that old as I am who remembers this movie? Come on, you are making me realize my age. Anyone respond? Matrix, yeah, I get it. Yeah, it's a Matrix movie, and if you have not seen it, then probably you have missed a lot of action. So this is Matrix Reloaded, and there is a character who is considered as a key maker. So if you look at that movie now, you would understand some of the concept related also. So Keanu is not paying me money to advertise his movie, but still you would be getting a little more good enjoyment for weekend. So check that movie. This is Matrix Reloaded. Thanks everyone. And what I'm doing now, I'm going to add Carl to screen. Carl, are you ready? I'm adding
Yep,
you to stream now.
good to
Thank
go.
you.
Yeah.
Thanks, Carl,
Okay.
again for coming up and sharing your knowledge. Carl is one of our AWS instructor. If you missed his last session, please check on YouTube. He is or he has delivered a phenomenal session on different communicate different type of security tracks. So just check that. It was very interesting. And today he is helping us with the encryption setting. Now I want to just quickly talk about that where we are in this system, like what we are trying to discuss and how our security track is formed. So if I look here, we have started this session like this. So we started first and talked about identity services, and then what we are concluding today is protection services. In protection, we talked about things like see my certificate manager I just explained you. Last time we talked about WAF and firewall, so that was an instructive discussion by Q that time. And then we are now focusing on the cloud HSM and KMS part of it. So this would conclude protection. And next week onward, we would talk about detection and then respond and then recover. So this is how logically we are progressing towards completing our security track. So I hope everyone is following along. If you missed previous sections, please check on YouTube. You should be able to find those details. So we are focusing now on this. So Carl, over to you. I would just keep myself a little relaxed and I'll let people enjoy your talks. If you want to
Thank.
share something, that's
Yeah.
fine.
Thank
Yep.
you, Ashish. Yeah. What I'm gonna do is I'm just gonna switch over like this, so everybody should be able to see a little mini me in the bottom of the screen. So, hi everybody. Let me just set my little timer to try and get this done in the right amount of time. There's a lot of material to go through, and the trick is always how to get the material covered in the amount of time that you have to cover the material. That's always a pain. Once again, my apologies. I am not going to be able to look at your questions live, but I will do my utmost if we have any time left at the end to cover those questions. So what we're going to be talking about today is basically going to be, what is KMS, the key management service in AWS, and how does the thing actually work? There's a lot of mystique surrounding this, and we're very lucky in that the KMS team actually published a white paper a few years ago, and they've been updating it, explaining how the KMS service actually works internally. So what I'm going to do today is I'm going to be focusing on that, and I'm going to show you the main use case. And there are many use cases, but I'm going to focus on the main use case of the key management service, and I'm going to show you how that actually works. And by understanding how that actually works, a lot of the things that's quite, shall we say, foggy and hard to get the grip on will suddenly become very, very clear. So some of the topics we'll talk about today to get through this material. First of all, we'll talk a little bit about what's so special about hardware security modules. And then we will talk about, the KMS service. So what is the KMS service? What does it do? How does it integrate? What are the components that we have in it? And in order to really make sense of all of this, I'm going to show you how some people might think encryption works, but it doesn't. And then I'm going to go and take a step back and say, okay, now if you want to understand how it actually works, we have to look at a thing called KMS keys. And there are a number of different types of keys that are being used by KMS. We're going to cover those. And then what I'm going to do at the end to make it really simple for you to understand, to be able to think through what's going on here is I'm going to walk through two operations. is when you generate the data key and when you decrypt something. Okay, so those are the two steps that I'm going to be looking at step by step, and I'll show you exactly how it works if you go through it. But let's first talk about data encryption and hardware security modules. So there's an open question here in the industry when you're talking about data, keeping it safe at rest. I mean, data in transit is, most people are now using TLS, thank goodness. But a lot of the time when data is stored at rest, it's not encrypted. And, why is that? So is it because it's hard to encrypt it? And I would argue that the encryption part is not the problem. The encryption part is easy. The algorithms are known. Implementations of those algorithms are out there. There's a lot of software and products out there that will do this for you. The trouble with encryption is not how to encrypt or decrypt something. The trouble is this. How do you handle the keys? And there are two aspects of the key handling. First of all, how do you ensure when you generate a key that that key is actually going to be a random number? So if you do this in software, that can be a very difficult, near impossible thing to do. In order to get better entropy when you're generating random numbers, you want to use hardware that's been designed specifically for that task. So that is the first thing that you want to be aware of. So you can't just use, I've got a web server or I've got some server and the server is going to generate some keys in software, which brings us to the second problem, which is where do you store those keys? And it's not a good practice to store the keys on a hard drive on a computer, for example. You want to ensure that keys are always protected inside of a little digital safe. So you need to have some sort of secure hardware that will not only generate the keys, but will also store the keys. And whenever the key needs to be used by some other external system, that external system needs to talk to the secure hardware and ask it to perform an operation on the key. The actual keys never leave the secure hardware in unencrypted form. Okay. So let's look at some of these types of devices that you have to generate and store keys securely. Now, a lot of you might have heard of a smart card. We use it a lot for all kinds of things without necessarily realizing it. Even if you have a mobile phone and you have a SIM chip inside of your phone, that is a particular type of smart card as well. If you don't want to use a smart card, most computers these days come with a special chip that's soldered to the motherboard of your computer. For the last 10, 15 years, they've been coming out with a thing called a TPM, or a trusted platform module chip, where you can, effectively get this hardware cryptography on a, say your laptop, for example, would typically have something like that. If you buy a mobile device, like an Apple, for example, they've got a thing called Apple Secure Enclave. More recently, they've got a chip called a T2 chip inside of an Apple device that stores and generates all of the secure stuff. And if you use servers, the type of hardware that you would typically use for this is a hardware security module or an HSM. Now, let's talk about exactly what happens to prevent people from messing with an HSM and why it is so special. And it's not just an HSM. I mean, even a smart card would have these countermeasures in some way, shape, or form. So first of all, they try to prevent you from tampering with it. I'm not going to go into too much detail here, but there are a lot of things that they do to make it really, really, really hard for you to mess with it. And a lot of these countermeasures that I'm going to be talking about here are also things that the vendors don't necessarily want everybody to know about, what techniques they're using. So these are some generic techniques that I'm listing here. These devices will have environmental sensors, okay? So it's temperature sensors, humidity, light, pressure, anything like that. If you try to freeze the device, all kinds of tricks that people might try. The device has got, booby traps to detect that if somebody's trying to pull a stunt like that. It's also got meshes on it, so, if there's anything that's cut or broken, that is going to cause a serious problem for the attacker because the device is just going to go mute. It also has stuff like this and a chain of custody. And this chain of custody is something that, prevents people from, it's almost like a man-in-the-middle attack between the manufacturing of the device and the use of the device. So from the point of it being manufactured until it's, given to the customer who installs it and uses it, you treat the cryptographic module like evidence would be treated at a crime scene. So going from the crime scene to the police to the court eventually, right? There's got to be a chain of custody. So these hardware security modules can be quite expensive as a result of this. So let's talk about how these hardware security modules communicate with other things like servers on a network. So you've got a server on your network, and your server has got a network connection in some way, shape, or form to a hardware security module like that. So the way that you talk to this thing is very much like, it's not like there's just like an Ethernet connection and it's got a network stack there running an operating system that you can talk to it like any other machine on a network. So the way that this works is a lot more like a terminal talking to a mainframe. Think of that pattern, okay? So what you do is you at the server will send a command to the hardware security module and say, I want you to do something. Now, this is just something that it's just a generic pseudo command. So say, generate a key pair for me. Okay, so you ask it to generate the key pair, and then, it will go off and generate the key pair. A few things I want to point out is before the thing does anything, every time you send a command to the HSM, it's actually going to go through that entire battery of tests. It's not when you turn it on, okay? It's sure when you turn it on, but not when every time you send a command to it, it goes through all the tests. Has this temperature changed? Has anything been tampered with? Is there any moisture in the system? Has the pressure changed? Has any of the tripwires been cut? Any of that. Every single time you send a command. Okay. So you send a command to it to generate the key pair. Now, sometimes, depending on how you configure the thing, it's just going to go and generate the key pair, for you. But for higher security operations that's got, say, very, very sensitive keys, for example, or very sensitive operations, it can even have another, shall we say, a step in the loop. So you can have a hardware security module where security officers in your organization have to connect with a keypad and a smart card that they put in that keypad that connects to the hardware security module. And then they say, yes, I approve this, cryptographic operation. It can go ahead. And sometimes for super, super sensitive keys, you have to have an entire quorum of security officers. You get 3 or 4 or 5 of these security officers, one by one, entering their smart card into the PIN pad, entering their PIN, and approving it, one after the other. It's almost like launching, nukes or something, if you watch these Hollywood movies. So that is typically something that is available as an option on the higher end hardware security modules. And provided that everything then is okay, the HSM will then go and send a response. Say, well, I'm done. And if it was a public-private key pair that was generated, it would typically go and then return to the server, not the private key part, but the public key part. Okay. So that is effectively what they do. Now, there are a few problems, or shall we say challenges, with this whole system. So first of all, this is what makes it hard for companies to implement this. So first of all, a lot of these commands are proprietary. So every HSM vendor's got their own proprietary extensions that, they make it, in order to be able to talk to the HSM, you need to have the vendor's software on your server to talk to that thing. Okay. Because the vendor software is the only thing that understands those commands. Of course, everything else here is also proprietary. So that and that, if that comes into the mix. But most importantly, and people don't always realize this, and vendors don't exactly advertise this from the rooftops, but HSMs have very, very limited storage. 10 years ago, when I was working with these things, you would typically see the higher end HSMs. I mean, it's something that cost you anything from $10,000 to $20,000 per unit, would have something like 10 to 15 megabytes, not gigabytes, megabytes of storage inside of the HSM. Excuse me. So, it typically would store keys, but it's not going to store a lot of stuff, and you can't put a lot of data in there. Okay, so that is a typical limitation. Well, I shouldn't say limitation, but a challenge with HSMs. And it's really, really hard to deploy the stuff at scale in an organization. So not many of them do it. Enter AWS KMS. And I'm still in awe with what AWS has accomplished with, the KMS system. It's almost like the iPhone. And I'm using this analogy because what the iPhone did for, mobile, should we call it computing, in a way is very much what AWS KMS is doing for, encryption. So they take something incredibly complex on an iPhone. They take effectively an entire computer and they shove it into a phone, but they wrap this complexity in incredible simplicity. So you just, well, how do you interact? Well, you have a touch screen. The same thing with the KMS system. So we've taken this HSM business that's really, really complex to work with, and we've wrapped it into something that is extremely simple to use. So it's almost as simple when you're actually using this as just ticking a checkbox and saying, yes, I would like to encrypt this disk. What key do you want to use? That one. Okay, we're encrypted. So let's talk about the, shall we say, the biggest use case for the KMS system. That is going to be what I refer to as symmetric envelope encryption, and not symmetric envelope encryption that is used by you and saying, oh, I want to talk to KMS and say, give me a secret key, and then I have that key and I can know. This is the use case pattern where AWS services actually ask the KMS service to do something on your behalf. So there's over 120 AWS services that are now integrated with KMS. And KMS is considered to be a foundational service in AWS. It's got to be pretty much everywhere. So what are the main actors in this dance when you're interacting with a KMS service? So obviously there's the AWS KMS service itself, but the AWS KMS service is not an island. There are actually a few other components that's useful to be aware of. So there is one part of the service, just the AWS KMS service, and then there is another thing called the AWS KMS HSM. And this is a stateless fleet of hardware security modules that are deployed in the AWS regions along with a KMS service. So those are two things that are very important, and they always work together. And then there's another thing that people might not realize, but there's also an AWS storage component. And the AWS storage component is used whenever you want to evict keys from the KMS HSM. You're going to send them into storage. It's going to be encrypted. So the KMS will encrypt something that is inside of it that needs to be exported, and it will be exported to some sort of storage over here. And then when that is needed again, the storage will be used to go and, the KMS service will go and fetch it from the storage and send it back into the HSM where it will decrypt it to use it. So that's sort of the KMS part. And the services, or 120 different services on the other end, like S3 and EBS and DynamoDB, and all of those services that can use encryption are the things that actually interact with it in this particular use case, which is really the main use case for KMS. Now, another thing I want to point out here is that there are really two worlds when it comes to, hardware security modules and cryptography. I call it normal world and crypto world. And if we did not have this KMS service sitting over here between the rest of normal world, it would be very hard for anybody or any service to interact with that KMS HSM. Because that is like, it's really, really deep technical, it's very hard. And to, for example, say, oh, I would like to, give somebody permissions in the AWS ecosystem to go and do something on an HSM is just going to be extremely, extremely hard and not very practical. So this is almost like an abstraction in a way, where you have the KMS service itself that's abstracting all the complexity of what's going on there. So all of these services can now go and interact and make use of this incredible complexity, but also very powerful system. So the way that they communicate with each other is simply this. Any of these AWS services, if they want to use KMS, they're simply going to make an API call to the KMS service. And this is going to happen over TLS, of course. The AWS KMS service itself is also capable of talking to the storage service, and it's also going to be talking to the KMS HSM like that. So that's some of the communications. Now, what I'm going to do next is I'm going to show you how it actually does not work. Now, some people might think this is the way it works at first glance. When you first get exposed to this, you'll go, okay, I think it works like this. It doesn't. Let me show you how it doesn't work, okay? So let's just set up the wrong, use case over here first. So some people might think it works like this. So there's a user over there on the left. And then you upload a 50 megabyte file to S3. And you say, I want to encrypt this file with a particular KMS key. My key 123. No. Now remember, it doesn't work like this. And then people might think, well, okay, so S3 will then send that 50 megabyte file to the KMS service and say, okay, encrypt it with this key. And then the KMS service will send that 50 megabyte file into the KMS HSM and say, okay, there's the file encrypted. And then the KMS HSM, encrypts the file. No, it doesn't. And then it sends it back to KMS, sends it back to S3, and then S3 say, okay, right, your file's been encrypted and stored. Now, I just want you to understand this is not how it works. And a few reasons why it doesn't work like this and will never work like this is, first of all, those files will never fit into the HSM in the first place. There's not enough storage in there. Okay, so 50 megabyte file, maybe it's got, I don't know what the storage is on an AWS KMS HSM, but that is not, it's not big. Okay. The other thing is it's going to cause an enormous amount of network traffic. So that is a problem. And it's also going to create an enormous amount of latency. Okay, so this is not how it works. So let's talk about how it works. But before we do how it works, we have to give you a little bit of background on one more thing, and that is the keys. So there's a lot of keys involved in this process, and there's been a lot of confusion over the years, when people, and in a way, I suppose it's, the way that we do the training and the way that we do the documentation, trying to make it simple, we oftentimes just abstract things and don't give you it's almost like the nitty-gritty detail of what's actually going on. But we're very fortunate that a white paper has been published now for a few years already, and all of that nitty-gritty detail is in there. So what I'm now going to try and do is to simplify what's in that white paper for you to understand what's actually happening at a level that will make sense to you and enable you to have a deep insight into how KMS actually works. So let's talk about some of these keys. I'm not going to talk about all of them, but let's just give you a list of all the keys that are in play, and then I'm going to cover them all one by one. The first one is the so-called KMS key. So when you go into KMS and say make a key, that is your KMS key. This is not an actual key. It's not a cryptographic key. Okay, we'll talk about that in a bit. Then there is another type of key, and this is the actual cryptographic key. Okay, it's called an HSM backing key, and it's usually referred to as the key material. So whenever you see in the documentation or in the user interface a reference to key material, that refers to the HBK or the HSM backing key. The HSM backing key is generated in the HSM, but it can't stay there forever. It's only in there when it needs to be used. And if it's not being used, it gets evicted to storage. It gets encrypted first and then evicted to storage. And that storage version of that key, when it's not in the HSM, is called the EKT or the exported key token. Okay. Now, the key that does the actual encryption and decryption of your data is referred to as the data key. Oftentimes, it's also referred to as the customer data key. If you read the white paper, they're referred to as the CDK or the customer data key. When you do an actual API operation on it, it just refers, it's just called generate data key. It's called the data key. So there's a little bit of ambiguity there. But whenever I say data key, I also, I'm referring to the customer data key. That's the thing that actually encrypts and decrypts your data. And then lastly, there's a thing called the data encryption key. So 1, 2, 3, 4, 5 keys to get your head around. Okay. So for the rest of this module, I'm pretty much going to be focused on explaining to you exactly how these keys work, what the process is. But before we do that, if you've never actually seen this, let me just do a very quick demo and show you what it looks like if you go into AWS and create a KMS key. So let me just jump in there real quick. I'm just going to go back to services. Let me just type in KMS. Okay. So I'm going to type key management service, go into the key management service, and say I want to create a key. So create the key, and I'm going to use the default settings here, which is a symmetric key that's used to encrypt and decrypt. Now, if you want to, you can also go to advanced options and specify where you want your key material to be coming from. The only use case that I'm covering here today is this one. This is also the recommended one. This is the main use case for this, okay? There's not enough time to go into the others. Some of them are really fascinating, but we're just never going to finish. So I'm going to talk about this use case over here only today, where the keys are coming from the KMS HSM. Okay, so I'm just leaving it at that. I'm going to say next. And now I have to give the key a name. So I'm just going to call it Visa Key 1. And next. Now, I'm not going to talk about policies in any shape or form today. This is something that is a very important topic, but I'm not covering it now. Just understand that in order to use a key, you're going to have a policy that lets you use the key. So you have to say who's going to administer the key, and I'm just going to select myself as the key administrator, and I'm also, for this demo, just going to select myself as the key user. You typically wouldn't do this in a production environment. You'd separate the roles, but we can't talk about that now. Just, take it from me. You need to understand policies in order to really get the most out of it, but we're not covering that today. So there's a policy. I'm going to say finish, and it's now got, and it's generated a key. So this is a KMS key, and the KMS key has got this friendly name here called the alias, and it's also got an ARN, or an Amazon resource name, and that there is the full, shall we call it, way that you can reference the key. So you can refer to it as the alias or the ARN. Both of those will work depending on the context, and that is your KMS key. So now that you've seen how you create a KMS key, let's just talk about exactly what that thing really is. Number one, it's not a key, okay? It's not a key. So the KMS key is not a cryptographic key. So what I want you to do is to think of the KMS key as an entry in a database that's sitting on KMS, the KMS service, okay? Once again, this is on the KMS service, not in the HSM, in the KMS service. And it's got a name, and it's got an ARN, and it's also got some metadata. And that metadata would be things like the policy that we just created, right? Or some of the attributes of the key. And some of those attributes would be things like, where does this key point to? Well, this key points to an actual key inside of the HSM. So that stuff will all be stored in the attributes of that key. So here's what it actually points to. This is the HSM backing key and its corresponding version of that key, which is not inside of the HSM, the exported key token. We'll talk about that a little bit more later. And once again, let me just point something else out if it's not obvious. The KMS key is not used to encrypt or decrypt anything in terms of your data, right? It doesn't encrypt or decrypt. It doesn't do encryption or decryption. So it's not a real key. Neither does it use, the KMS quote-unquote key to derive another key to do anything. So that is something that I want to get very clear. And there's some confusion over this. So hopefully that will clarify. So let's look at some of the other keys that are real keys, starting with the HSM backing key. Now, the so-called key material, right? So this is associated with the KMS key. How? Well, inside of the KMS key, there is an attribute that says, whenever you create the KMS key like we just did, the KMS service talked to the HSM and said, create for me some HBK material that I'm going to associate with this key. And it generated that HBK, and then it exported it out of the HSM to the storage. And now that key has got inside of the database, inside of KMS, those attributes to say, okay, it's pointing to this real key, and that is the actual HBK. Okay, so it's associated with that. It's generated inside of the AWS KMS HSM. So it doesn't get generated in the KMS service. It gets generated inside the hardware security module as part of the key creation operation. So as soon as it's been generated, it will typically then be evicted from the HSM in order to, save space and clear space for other operations on the HSM. So it's going to be encrypted by the HSM, and then that's going to be exported to AWS key storage. Okay, so that is the online storage. In its encrypted form, this is what it's called, the exported key token. And the reason why this happens is because you don't want to have the HSM fill up with a bajillion keys. You know, it will fill up really, really fast. And when that is required for some sort of a key operation, the HSM backing key is going to be imported into the HSM and then decrypted inside of the HSM to be used. Just be sure it never leaves the HSM in unencrypted form. And as I've already said, details about these are stored as metadata attributes of the KMS key. So you remember the screen over here when you created the key. Just remember what we're talking about now is this one over here. Okay. So this is the KMS key, and this is when the HBK is generated inside of the KMS HSM. There are some other use cases here as well that we're not going to cover, but this is the main use case by far. So let's look at where those keys will actually live. In other words, the KMS key, the HBK, and the EKT. So first of all, the KMS service itself over here is where the so-called KMS key lives. You know, that is where that lives and where that is used. Once again, think of it as a database on the KMS server that's storing that information. The HSM backing key is generated in and used inside of the KMS HSM, and the exported key token is, you know, the exported form of the HBK when it's not inside of the HSM, like that. Okay. Now, having covered all of this and having said all of this about all these different keys, this might come as a surprise to you, but and I want this to be clear, okay, because there's some confusion over this. None of these keys, neither the KMS key, the HBK, or the EKT, actually encrypt or decrypt any of your data. So, okay, if you upload something to S3, none of those keys actually encrypt or decrypt your data. So let me just repeat that. Okay. So what does the actual encryption of your data? Now we'll talk about that in detail soon. But there's another key that does your data encryption, and that is called the data key, also known as the customer data key. And we'll talk about it more in a moment. And don't pull out your hair when I show you the next bullet point. The job of the HSM backing key is not to encrypt your data. The job of the HSM backing key is to be used in a derive operation to derive another key called the data encryption key. Don't pull your hair out. It will become clear in a minute what's going on here. And the data encryption key does not encrypt your data either. It encrypts the data key. So the rest of this talk is going to explain exactly what the processes are here and what's going on. So if you're feeling like, you know, this is just getting out of control, don't worry. We've gone as far to the edge as we're going to go. Okay, we're not going to go any further than this. So, okay, there are 5 keys now. So let's look at, you know, what's actually happening with envelope encryption. What I'm going to show you on the next slide is the stuff that gets simplified in the documentation and the training. And that makes it very unclear what's going on. So I'm going to try and make it crystal clear, and I'm going to give you 2 swoops of this. I'm going to show you how they all fit together relative to each other, and then I'm going to show you 2 operations, you know, getting a data key and then using it to decrypt something. So the full story of envelope encryption is as follows. You begin with your data. So that would be an object that you've uploaded to an S3 bucket, for example. Or it could be an EBS volume that you're storing, you know, your machine's, you know, hard drive, right? Your EC2 instance's hard drive. So that is, you know, your data. Your data gets encrypted by using the data key or the customer data key. This is the only thing that ever actually does the encryption of your data or the decryption of your data. None of those other keys do anything. So I like to just point this out very, very specifically. Okay. And a new one of these is generated inside of the hardware security module every time you request a data key. So if you go, for example, and say, I would like to, you know, let's say, go and create a new EBS volume, and I want to encrypt that EBS volume, the EBS service will go to KMS and say, I want a data key. And it will for EBS will actually generate two of those, by the way. I want a data key or two data keys in the case of EBS, and then that gets sent back to the service. And that is the symmetric key that gets used by the EBS service to encrypt and decrypt your drive. So let's see where the other keys fit into this picture and what the relationship is. So let's begin with the KMS key, which isn't really a key. So the KMS key is a database entry effectively on the KMS service, and it has attributes in that database entry that points to the HSM backing key. The HSM backing key, in turn, is now used to derive a thing called the data encryption key. And the data encryption key is the thing that encrypts the data key. So this is the envelope part of the envelope encryption, right? So now you've got two versions of the data key. You've got the plain text data key, which is not encrypted, and you've got the encrypted data key, which was encrypted with this data encryption key. So both of these are the same key. And every time in AWS, when you go and say, give me a data key, it's going to go through this whole process. Okay. So remember, the data key gets generated uniquely, independently, every single time you say, give me a data key. And the role that the KMS key, the HBK, and the data encryption key have in this operation is that it is going to be working not on creating the key that's encrypting your data. It's going to be involved in encrypting and decrypting the key that's used to encrypt and decrypt your data key. Okay. So whenever you have a service like S3 going to KMS and saying, give me a data key, it's going to get two copies of this key, an encrypted version and a plain text version. So the service itself will actually use the plain text version to do the encryption and the decryption, right? It will store the encrypted version of the key with the data, but I'll show you a little bit more on how that process works later. So there's always going to be two data keys, well, one data key, but in two forms, encrypted and plain text, right? And just to complete things over here, I wanted to show you that the exported key token and the HSM backing key is also the same key. It's just this is the one that lives in unencrypted form inside of the HSM. This is the one that gets exported and encrypted that lives in storage. Okay. So let's look at a few characteristics of the data key. So that is the actual key that does the encryption. And every time something needs to be encrypted using KMS, the AWS service that is trying to do the encryption is going to make a call to KMS, and KMS will then generate a new data key every time for that. Now, I don't want anybody to get confused. There's been some changes in the S3 service where what they do is they've got a thing called a bucket key. It's just a way to offload some of the work that happens in KMS. But this is traditionally the way that it works, and this is the pattern that I want you to understand. So just assume for now that you're not using a bucket key with S3. You're just saying, I want to use KMS to do this, and this is what it's going to do. It's going to create a new data key every time you want to encrypt something. Okay, it happens from scratch every time. So that data key is not related cryptographically to any of the other keys. It's just a new random number that gets generated inside of the HSM every time you ask for a data key. And the actual encryption and the decryption, and this is very important to understand. KMS doesn't encrypt your data. KMS encrypts the keys, okay? The actual data gets encrypted on the service that is requesting the keys. So if I go to S3 and say, here's a file, 50 meg file, please encrypt this file for me. S3 will go to KMS and say, generate the new data key for me. The KMS service will send that to S3. And S3 is the thing that's doing the actual encryption. Not KMS, the service does the encryption. And that's what we call server-side encryption, or SSE. And 120 plus services are integrated like this. Now, let me just show you very quickly what this would look like. Okay, so I'm going to just show you in my console. If we were to go and say, I want to go to a service like EC2, and I now want to go and I want to start an instance. So I'm just going to, if I say launch instance over here, it's going to walk me through all of these things. I'm not going to actually launch an instance. I just want to show you something. If I go all the way down here and I go to configure storage and I go and say there, I want to see advanced settings. Okay, so I expand that over there. So this is going to be my EBS volume for my EC2 instance. It's going to say, do you want to encrypt this thing? And I say, yes, please. Okay, what KMS key do you want to use? I want to use the one that we just created, the BISA key one. Okay. So in this case, it's the EBS service that's going to go to KMS and say, give me a data key or 2 data keys for EBS. And it's going to come back. And EBS is the thing that's going to be encrypting and decrypting your data as it goes to your hard disk and as it's coming back from your hard disk. So it's being read and it's being written to your hard disk. The encryption is done on the server side, on the EBS side, right? If you were to go to a service like S3 and you were to say, for example, create a new bucket, say create a bucket, and I'm going to call it my AWS BISA bucket 1, just to ensure that we've got a unique name for it. You'll see that now when you create a bucket, it gives you the option to just encrypt everything in that bucket by default. And I'm not going to talk about any of the other use cases. The one that I'm going to talk about is this. I'm going to say we want to do server-side encryption with the KMS service. So SSE KMS, that is the main, use case of symmetric encryption, symmetric envelope encryption. So I'm going to say, what key do you want to use? And I'm going to say, well, I would just like to go and use a KMS key that I've already got. So I don't have to generate a new one. Well, here's a list of all my keys. There's the one we just created. So I'm going to use that one. Okay. And I'm not, so this is, I'm not going to use a bucket key. It's a good idea to use a bucket key, but I'm not going to cover what's going on there now. Let's go and create a bucket. Okay. So now I can go and upload something to that bucket and it will be encrypted, and the encryption will happen on the S3 service, server-side encryption. Okay. So let's just jump right back. And now what I'm going to do is I'm going to step you through the process of generating a data key and what actually happens. And then I'm going to show you what happens when you use that key again. So this is going to go fairly quickly. So how do you generate a data key? This is what actually happens. So somebody goes to S3 and say, here's a 50 meg file. I'm uploading it to S3 and I'm going to say, I want you to encrypt this thing with my KMS key called my KMS key 123. Now, if you've gone and set up your bucket settings to just use default encryption of everything in the bucket using a KMS key, you don't have to specify that when you send the object. It's just going to use that, right? So it's going to hit the bucket. Here's a 50 meg file. And then S3 is not going to send it anywhere. It's just going to talk to KMS and say, please go and generate a new data key for me under the my KMS key 123 KMS key. Okay. The KMS service is then going to go and say, okay, the HSM, please generate a new data key from scratch inside of the HSM. So the HSM is going to go and generate that. And then what's going to happen is it's going to go and let me just see what's going on here. I don't know why. What I say, get the external key token. Yeah, okay. So once again, this is assuming that the so sorry, I just got a little bit confused here. This is assuming that you've already got a KMS key, right? Okay, right. So you've got the data key generated inside of the HSM. And now what's going to happen is that the KMS service is going to go, and not necessarily, it might be doing all of this, simultaneously. I just had to put it in this order in order to make sense of, the process so you don't get overwhelmed with the material on the slide. But the AWS storage here is now going to go and basically the KMS service is going to request the exported key token that is associated with that KMS key. Remember, the exported key token is an encrypted version of the HSM backing key. Okay, So it's going to go and get that, and then it's going to send that into the HSM. And the HSM is then going to go and it's going to decrypt that exported key token. So that is the first thing that the HSM is going to do. So now you've got the HSM backing key. It's just the unencrypted version of the exported key token. And then the KMS HSM is going to just go and generate a random nonce. Now, a nonce is a number that is only used once. So it's going to generate the random nonce, and then it's going to use the HSM backing key and the nonce to derive the data encryption key. And once it's got the data encryption key, it's going to use that to encrypt the data key that it generated in the previous step. And just to be absolutely clear here, because when we do the decrypt operation, this might come, some people might ask the question, so how exactly does this work? And, the way that it works is it will help to know that the encrypted data key has two sections. There's an unencrypted header and there's an encrypted portion. So there is some stuff in an unencrypted header, and it's just worth knowing about that is in there. So once it's done all of the stuff, it's going to flush, in other words, delete the HSM backing key, the data encryption key, and the nonce. So it's going to blow all of that stuff away. And then what it's going to do is it's going to say, okay, right. So here is the plain text data key and the encrypted data key. So it's sending that back to KMS. KMS is sending that back to the service, in this case S3. And S3 now, only now, performs server-side encryption on that 50 megabyte file. And when it is finished, it's going to flush the plain text data key. So it's using the plain text data key. So it's got both the plain text and the encrypted data key. It's doing the encryption with the plain text version of that key. When it's finished encrypting the file, it will blow away that plain text version of it. And then what it's going to do is it's going to store that file along with the encrypted version of the key that was used to encrypt it. Okay, so that is an actual encrypt operation in KMS and how it works. Here's how you decrypt something. So let's say we've gone through those steps, we've encrypted something, we now want to decrypt it. Here's what's going to happen. Okay, sorry, that was the last step. So here's decrypt. So here what we're going to do is to say, okay, I want to decrypt this, 50 megabyte encrypted file that you've got there. I want you to decrypt it and send it to me. So now what the S3 service is going to do is it's going to go and say, okay, right. So it's going to go to KMS and it's going to take that encrypted key that's stored with that data. And it's going to say, okay, so here is the encrypted data key, and it was encrypted under KMS key, my KMS key 123. Please decrypt it for me and send back the plain text version of this encrypted key. So there it goes. And then the KMS service is going to go to the storage, and it's going to go and fetch the exported key token that is associated with that KMS key. And then it's going to go and it's going to import that exported key token into the HSM. It's also going to import the data key, the encrypted data key that's been supplied by S3. It's going to decrypt the exported key token to get the HSM backing key. And then it's also going to go and extract the nonce from the encrypted data key. Remember, there is some stuff in there that is not encrypted, okay? So now that it's got all of that information, what it's going to do is it's going to use the HSM backing key and the nonce to rederive the data encryption key that originally encrypted this key. Okay, so it's going to decrypt that, and then it's going to get the plain text data key. So it will use the data encryption key to decrypt the encrypted data key to get a plain text data key. And that's what you're really after. Okay, so let me just see, actually. So I did the slide in a hurry, so that step shouldn't be there, okay? So what it's going to do is, so just forget about step 4. Let's talk about step 1 first. It's going to return the plain text data key to the service, and it's going to blow away the HSM backing key, the nonce, and the data encryption key. It's going to evict that to make space for other operations. So the KMS service is going to have that. It's going to send it then to the S3 service. It's going to use the plain text data key to decrypt the encrypted file using server-side encryption. And then finally, is going to send the file back to the user. So this is basically the entire story. Now, I'm finished now, but before I'm done, I'm quite done, I just want to show you what we did not cover here. So what I've covered here now is the basic fundamental mechanisms of how KMS works. I just want you to be aware that there are some other things that's worth knowing. We didn't really talk in too much depth on the types of encryption. Very important, we did not talk about the policies. So policies are absolutely fundamental to controlling who can do what. It's not been covered, and there are some very interesting nuances with KMS policies. There's also a thing called grants. Not going to talk about that here, but you can. KMS is a very special service in AWS, and you can you can use a grant in order to do stuff with keys, when there's not a policy necessarily in place that will cover that eventuality. Typically, when you don't know who the principal is going to be or how long you can use a policy to say, I want to issue a grant to something or someone. There's also a thing called encryption context. We haven't covered that, but if you go and create an EBS volume, for example, the instance ID would typically be in encryption context. There's also we didn't cover the key that's used to encrypt the the HBK when it's being exported as an EKT. I said the HSM encrypts it with what? Well, it's called a domain key, not covered here. Also, what is a deactivated HSM backing key? So where does your HBK go when you rotate it? There are some other keys above the domain key. It's all in the white paper. I'm not going to cover it here. We didn't talk about multi-region keys, which is a new feature. Key rotation, we didn't cover. Hint, hint. When you rotate the key, you basically replace the HBK, right? And then there are some sources of key material other than the AWS KMS HSM. And these things all use somewhat different mechanisms than what I've described here. So don't assume that they all just use the same mechanism. They have different ones. And last, final slide over here, in case you're interested. This is what the AWS KMS HSM actually looks like. So this is publicly available. If anybody's interested, I'll just put this into the, not into the chat for you, but I'll put it where somebody, I think probably Barna will be able to get it if you want to go and check that out, because this thing has to be certified to be FIPS compliant, and those documents are publicly available. So here are some photos of it. This is the actual HSM KMS, and it's very recently just been awarded FIPS 140-2 level 3. Okay, so it used to be level 2. It's now level 3 compliant, and this is where you can go and find the documentation on that. So I've overrun by a few minutes. My apologies. Back to you, Ashish.
To stream. This is amazing, Carl. There's so much information, so much of things happening behind the scene. The good part is like KMS just hides whatever is happening behind the scene, and we just consume it as a consumer. And that's the beauty what AWS is known for, hiding away the abstractions and then giving you what you actually need. And obviously this is very important stuff to understand. And people do not blame yourself if you did not get it first time. It takes time. It is still like it is still so much concepts there and so much layer of obfuscation and security embedded that it is not easy to understand it in one time. So don't blame yourself. That's why we do recording. Revisit this session, revisit the documentation which Carl would be providing, and probably you would have some understanding. Even if you get 20% of it, I would say you are far behind, far more ahead from most common folks, which would just understand what is KMS. But that is a very insightful session, Carl. Really, really interesting. And yes, probably we may have some time later maybe in the next batch, probably to go in depth of grants and then how the rotation happen and how the deletion happens. But yeah, this was very, very interesting stuff. Thank you so much. I know how much time you have taken to put this together, slide deck and all the stuff. But yeah, that is mind boggling, like what is happening behind the scene, and you were able to put it in simple animated format, like what is actually happening. Thank you so much.
You're most
People who
welcome.
are not able to comprehend, don't blame yourself. We will have recordings or revisit it. As somebody said in the chat, you would need more time to decrypt what just happened. So just invest a little bit more time and that would work for you. Thank you so much. And we will hopefully see you in another session, Carl. And if you could just drop in that white paper link, we'll post it into
Yes,
the resources section.
I
So
will
we
do
would
it.
be, yeah, thank you so much. Now let's move forward to the next topic, and we would be now talking to Jonathan. Jonathan is one of the account manager in AWS. Welcome, Jonathan. I'll add you to stream now. Here you go.
Hello. Hi guys.
Hi, hello. Thank you. Thanks for joining, Jonathan. Interesting to see you on Saturday morning. It was short notice, and but hopefully that. Thank you for your time, and we will have lots and lots of interesting discussion as we move forward.
Yeah, no worries. Firstly, yeah, I'm definitely as someone who sat in there for some of Carol's presentation. I'm definitely someone who's going to have to revisit a lot of that content because, yeah, struggled a lot with it. But no, yeah, super happy to be on and just I suppose sharing my side as an account manager and just I suppose a bit more about my role. So yeah.
Nice. So if you could formally introduce Jonathan, what is your role in AWS, which office you are in, kind of?
Yeah, perfect. Yeah, so I'm an SMB account manager based in London. So I help small to medium sized businesses maximize their investment in the cloud. That's how I like to see it. So often, small to medium sized businesses they face common sort of challenges and also opportunities posed by the cloud. So things like cloud migration, modernization, and also kind of new product development. So my role really is to act as sort of like a signpost for these businesses in the cloud to ensure that they're speaking to the right teams at the right time to really just execute their IT strategy. So that's kind of a bit about my role, I suppose.
Great. So when we say SMB, what is the criteria AWS uses to call some businesses SMB and to some call enterprises?
So the SMB business is any company with revenues under 100 million
Hmm.
a year. So that's how we bracket it. Generally, that's kind of just an indicator, and some companies may be bigger than that, and also some customers may be way smaller than that. So it does vary quite a lot. But I think the exciting thing about SMB businesses is you're really helping them. You're helping them bridge the gap in between becoming sort of like that sort of small business to really that kind of enterprise business. So helping iron out those sort of challenges. So it can vary. And the nice thing is that you can be on that transition with your customers from ironing out those teething problems of on-premise migrations to really becoming an innovator in the cloud and becoming that big enterprise customer.
Great, that gives good insight. And if I have to define the role of account manager, who is an account manager?
An account, the role of an account manager, I did touch on it. Like what I think our role is really to be that first point of contact for
Hmm.
businesses when they're engaging with AWS, and we work very closely with our solutions architect team to provide that sort of like the technical side of it. But really, what we are like the kind of gatekeeper to make sure that if there is any request from the customer that we're ushering those requests to the right teams that they get kind of a swift answer. But as I said, like we provide that sort of more the kind of business lens, and then the SA alongside works alongside us to provide more of that kind of technical lens too. So it's kind of like a collaborative effort in terms of how AWS supports engaged customers.
Great. Now, if I'm talking from a customer perspective, let's say I'm a AWS customer, at what point in my journey I would get connected with an account manager?
It that can really vary. I think
Hmm.
like so like I suppose I'm happy to I think I'm happy to kind of go through like the various different, I suppose, modes of engagement. If that sounds
Yeah,
good,
yeah,
yeah.
absolutely. Yeah.
Yeah, so I think in terms of, to provide a bit of context just on like the types of meetings we have. So generally we kind of have generic meetings and also kind of strategic engagements. So for kind of net new customers, so these are customers who AWS, they might have started to bill on AWS and they've emailed to reach out to look for support via tickets or contact us forms on the AWS website. We then they connect to our account management team. And on those first kind of calls, I suppose I do kind of quite a bit of research to understand what their business is and the industry they're in and how we can maximize value on that first call. So what technologies might they use, and how can we support that? And myself and the SA usually would have a pre-call just to discuss, this is an interesting customer. Is there any case studies we can share? What are the trends that are going on in their industries? And really bring them to the forefront on those first calls, because I always think it's important not just to make those first calls reactive in terms of a customer asking you the questions, but also questioning the customer and saying, are you interested in this area? So if it's the first time meeting with the customer, what we do look to do is get a kind of 360 view of their business to understand how their kind of business integrates with their IT infrastructure. And after this, we as an accounts team are better positioned to understand how to support their kind of unique goals. And me and one of my SAs, we have 4 key areas where we try to understand for these net new customers who've never spoken to AWS. We want to understand what are the data strengths that we can build on with them? What are the blockers that are currently facing them? What are the key projects that can accelerate scale for their business? So what's going to grow their business over the next 3 years? And also, what are the kind of think big ideas? So are they looking at Gen AI? Is it going to be about new product development? So this gives us as an accounts team, an SA and myself, a really good foundation as to where we can work with net new customers. But I must say it is a bit strange when you're going into those calls because they can vary quite a lot. Sometimes, this format of trying to find out a bit more about the customer can work really, really well. And some tech teams can love it. Others can be very reserved, closed off, and not want to talk and open up, which is another sort of challenge. So yeah, that's the kind of net new customer. And then for the existing customers, we generally would have some sort of planned pipeline of projects that we're working on with them. And generally the check-ins with customers that I have, and usually I try to have them on like a monthly basis with bigger customers, and maybe more spread out through the year for customers who don't need like as much support. And what we try to do is really just, a lot of them are more technical focused, and we'd align SAs and specialists to make sure that they have the knowledge to execute upon planned projects. So if they are doing a project, what are the blockers they're facing? Is there any additional information that we can share with them? And really just helping them get to the crux of anything that's halting any innovation. So that's the kind of other side of it, where the customer check-ins is a lot more about, I suppose, how we can best support the existing conversations that we've had.
Great. Now, this program is for people who are looking for getting into cloud roles. So I want to understand from you, like, what are the skills which are advertised in the job description or the JD for account manager? So when AWS wants to hire an account manager, what skills they look for?
Yeah, I think like obviously a clear demonstration of the leadership principles. And I think with an account manager, customer obsession turns into somewhat of like they want to see customer addiction, another level of customer obsession as opposed to customer obsession. So they're really keen to make sure that whether that be so for a bit of background about myself as well. So I started out my career wanting to always go into kind of finance and consulting. I think movies like The Big Short and Wolf of Wall Street somewhat glamorized those jobs, and I quickly understood after working in those industries that I wasn't really working to my to my strengths. So it made me kind of reconsider. But what they looked for when I was applying, even though a lot of this wasn't customer facing, so when I was in finance, when I was working in consulting, I wasn't very much customer facing, but what I did have internal customers. So my customers were my stakeholders. So they really like made sure that those relationships were ironed out. So definitely the customer obsession is really important. Earning trust as well, especially was something that, on those initial calls, like you heard about, like what a net new customer might look like. It's really integral that you're able to build trust quickly with the customer and to show that we're more of a strategic partner as opposed to a service provider to our customers. So that's also quite important. And I think probably the biggest thing that they looked for on is that the ability to galvanize teams as well, I think, is really important for an account manager. We know as an account manager, we rely so heavily on the likes of solutions architects, specialists, and our internal tech teams to support and create compelling customer journeys for our clients. And really, I think being able to bring that out of our internal teams and SAs and working as one kind of collaborative team, that's really important to, I suppose, creating that good environment for a customer to flourish in. But as always as well, I think just one other last thing is that showing yourself to be a doer is so important in the account manager role. So like doing your day job and engaging with customers is one thing, but what are you going to do outside of just having that customer call to make sure that firstly, your customers are getting the best experience possible on our platform? And also what other kind of projects are you working on to, maybe make processes better? It might be gain more insight about different, different trends that are existing in your territory. So I think that, customer obsession, earn trust, and being a kind of doer and going above and beyond and bar raising in other aspects outside of the core role are the three main things I'd highlight.
That's good information. Now, if I try to divide the task by task basis of your day, so I'm guessing that you do a lot of communication and coordination, right? Any other type of task which you get involved, which people may not know, but you do it on a day-to-day basis?
Yeah, well, I think the first, I think escalations and outages can definitely sometimes, so if we do come across sort of an outage or an escalation, that does have to take priority, especially if it's a productionized workload. So, putting all hands on deck and supporting them in terms of resources is important for that. So I think there is kind of a reactive element that, customers come with you with issues. It might be something to do with billing. I think that's sometimes overlooked, because when a problem like that arises, sure, it doesn't happen every day, but it might happen monthly. That can take a day or two of back and forth with teams to make sure a customer's back up and running, or to make sure that billing and things are ongoing. And I think another I think a lot of it, the organization, especially for strategic engagements. So for example, this week I held a Gen AI workshop with a customer, and also another ML, just an ML workshop as well in an offsite with a customer. And these sessions take quite a lot to organize and bring in the right partners and specialists. I think that's probably something that SAs, I'm not too sure, would see a lot of, especially the partner piece. Understanding where our partners sit in terms of our customer needs and aligning them accordingly is something that you have to take the time to work with these partners, understand what their USP is, and then align them accordingly from that perspective. So I think that's definitely something that I suppose SAs mightn't see the whole time. So I think there's the escalations piece, definitely that takes precedence some days. The planning of kind of in-person deep dives and strategic engagements could take up quite a lot of work, and also the kind of partner engagements and making sure we have the relationships built up with our partners, because also our partners can be our kind of scale arm too. So when SAs and account management teams, when we're kind of overloaded with a lot of works, working with a consultancy partner to lean in and maybe support a customer with the implementation and the hands-on keyboard work that an solutions architect can't do. I think that can be important too. So yeah.
Great. Talking about what metrics are used to measure account manager, like what do we say that this is successful person, this is struggling, or there is some changes required? How the metrics are calculated, or what metrics are calculated? I would be interested in what are the metrics for a successful account manager.
Yeah, so like I think the metrics the metrics we have, like they the biggest one would be kind of opportunities created. So in terms of like what are the conversations you're driving with your customers that our accounts team can lean into.
Yeah.
So really that's what, solutions like our SA team, they will then work, their role is, so we create opportunities, we have conversations with customers, and then our SAs will lean in to make sure that our customers have enough information and enablement to action said opportunities. So there's the opportunity creation side of things, so making sure that we have enough of these conversations going with a wide cohort of customers to overall lead to a more kind of successful end business. Then launch opportunities. So these are opportunities that, we've created the opportunity and they've now progressed to the customer adopting said service. So for example, if we had a conversation about data warehousing with the customer, I would create the opportunity about data warehousing. The SA would then lean in, explain what Amazon Redshift is, maybe have a few more calls about what that might look like implementation, and the customer will then decide to adopt that service, and then we would kind of launch that as an opportunity. So that's they're the kind of two key metrics that I suppose we're mainly launched on, and obviously revenue would be part of that kind of launched opportunity metric too.
Makes sense. And talking about like when you are interacting with a solution architect, what kind of conversation that looks like? When you engage
Yeah,
those
so
people, or when you reach out to them, or proactively, reactively, how is that communication channel between a SA and an account manager is?
yeah, like I personally, and this is up to kind of unique styles. Some account managers prefer to have a more kind of formalized channel, but like what I do is I will have, before a call and after a call, I'll always have 10 minutes with my solutions architect, just to make sure that we're prepared for a call and we're also aligned technically for the follow-ups. So I think from a customer perspective, that's what we do. And we also have monthly kind of strategic calls of like pipeline reviews. So that would involve looking at the created opportunities and seeing where we see opportunities, for an SA to support or lean in or get a specialist to support. We'd also like discuss that as well. And I think what for me with my SAs, I think a good SA, like what I think my SAs are brilliant at doing, is a good SA will kind of tell me and tell my customers how a service can work, but a bar raising SA will explain why a service can help achieve a business's objectives. So they're quite clued into, okay, not just how a service works, but why a business is going to adopt that service. And I think what my SAs have gotten brilliant at is understanding not just what a customer is using, but like, how that service is going to, grow their business, or what is the actual tangible business outcome. Is it increased revenue? Is it productivity? Is it cost optimization? So they've been really good at forging those conversations. And being completely honest, as an account manager, it really bolsters my position if I have a solutions architect coming to a call with a customer and talking about the business drivers to do things, because it it just earns a lot of trust with the customers. And some SAs may think that they're doing my job for me, but I think that that's all. It's brilliant when we both go in and we're kind of having these discussions about how business ties very closely to IT.
That's the interesting part, yeah. And So do you work with a specific set of essays, or that is a rotational, or you engage them based on specialty or a business or domain requirement?
Yeah, so we have two dedicated solutions architect aligned to my territory. So I'm made
Hmm.
up of three other account managers. Um, in total, our territory has around, I think it's 900 accounts, and around 200 of them are engaged. So, like engaged accounts, meaning that they're billing on the platform, and the rest are net new customers. So it's a nice mix. And I think the really good thing about SMB, and the thing I like so much about it, is the variety of customers that we deal
Yeah.
with, and how it's never one set thing, and it really makes you sort of think on your feet, but also learn so much about how cloud computing can affect various different industries. And I think that's something that me and my essays, we really enjoy doing, is like before a call, investigating a bit. And we're by no means going to be subject matter experts for any of our customers. I think that's not what we try to be, but we try to, I suppose, just understand where we can kind of lean in and support, and having case studies and things to check up on is always good as well.
Great. Now, I would pick up some question from the audience, Jonathan, and that would probably give them idea also, and will be making this conversation fruitful for audience also. The first question I'm sharing here with Chandrasekhar: is account manager different from a TAM?
Yes. So one of my customers has a TAM aligned, and the TAM is absolutely brilliant. But the difference, I think, between an account manager and a TAM is your account manager is a lot more commercially focused, let's say. So I
Hmm.
think and I go back to the analogy I said, like we really are the navigator for businesses in the cloud, as opposed to the technical navigator, if that makes sense. So I think that what we do is we might pull in the right people, send out the right emails, organize in-person events and things like that, whereas the technical account manager will navigate that from a service specific level. And what that might look like is, I think with the technical account manager, you have like generally you'd have around like monthly cadences where you'd talk about different themes over the month, and how that might how a customer might action those. And it's also things like architecture reviews and enablement for their teams. So basically the TAM is a lot more technically focused, but still is more forward looking. Like from they're forward looking from a technical perspective, whereas an account manager is more commercially focused. So how can we kind of maximize their investment, maybe through funding programs and bringing in the right people to support that?
That's insightful. And for people who are on call, next week we have a technical account manager coming on the call, so you would be able to see the technical part of also the customer engagement. So thank you. Now, there is a question which is not very perfectly aligned to what we are discussing, but still I'll pick it up. Is it similar to a business analyst role, your role? I hope not, but yeah,
No,
let you comment on that.
yeah, no. So a business analyst, or like it depends, I suppose, what a business analyst role is. If it's in like finance and things, it's a bit different. But I think my role isn't so much on the analysis side, because it's a lot more customer focused. We do
Hmm.
have business development teams who are responsible for like identifying pockets of growth in different industries, and might be able to like create tailored go-to-market. So for example, in energy and they'd look at, let's say you had an energy and utilities business development team, and they deep dive on AWS technologies that are growing in said industries, and then they can recommend maybe go to market packages that a customer can adopt and deploy quite simply in those industries. So there is those roles that are a lot, but they'd be a lot more internal facing, quite data heavy in terms of looking at usage patterns and things like that. But whereas my role is very much customer facing, it's all about the customers. For context, I had so this week I had 2 all-day workshops and then 3 customer just check-in meetings with customers. So every day there's almost a new customer. So it's about just a lot more customer facing than that.
Great. I'll pick up another question, and that is about how involved you are in cost management. I'm curious how the predicted cost for a business would compare to actual cost of business.
So I think cost optimizations is a really interesting one. Some account managers might not be that interested in it. I see it as a huge opportunity for reinvestment in cloud. A lot of the time, like customers will, cost optimization will earn trust to make sure that, in the future they're going to be adopting new services, and just that earned trust piece, that we're going to be that strategic long-term partner that's acting in a customer's best interest and not sending them down the path of a service that's massively overspec and they're going to be disappointed with. So yeah, we encourage our customers to do well architecture reviews every 6 months. So that's something that our SA team work with us on. And predicted costs for the business, like if that's in terms of like migrations and things like that. Usually when we're doing predicted costs and pricing calculator, that can be kind of the worst case. Like it's a lot of the times that's kind of the worst case scenario. So when a customer actually moves on to AWS, there's further cost optimizations to kind of happen. Things like savings plans and RIs can be taken out, and that can reduce costs. So I think predicted costs can sometimes can be can be overestimated, but that's a kind of good thing because it's
Yeah.
customers aren't getting frustrated. Yeah.
Yeah, exactly. Yeah, I get it. So thanks for that. And the second question is also on the similar line, but this is on an implementation part. Do you also help the customer stay within a budget?
Yeah, we definitely do. Like I think it depends on the project, and I think that the nice thing about pay as you go pricing is that we can be kind of set to a budget, and we can know what what the usage may be for a set amount of customers. Now, look, if you have the fortunate benefit that you onboard onto AWS and your cloud usage like spikes because you have so many users, generally businesses see that as a kind of good thing. So
Hmm.
if it's a new, or like let's say you've adopted like AI and it's a brilliant chatbot or something like that, if customers are really using that and your AWS spend spikes, you'd hope that it's budgeted in, that there's a return on investment for any of those services that they're adopting. So generally, I think, we try to make sure that sort of happens. So I think that there's always a purpose for a customer adopting a service. They're not just doing it for the sake of it. But in terms of like budgets for things like migrations, like that is something that's ongoing. And one of the things is that we're very transparent with our pricing. Customers can go on the pricing calculator, and it's not really up to me sometimes to make sure customers within budget. If they go over budget, I will always work to make sure that we can try get that down to the minimum viable spend. But if that's not
Hmm.
always the case, it's we can try work around that too.
Great. Now I have a very tangent question. Like we have startups team also, and then we have SMB team also. So who makes the transaction? Let's say I'm a startup, then I've been with AWS for a long time. So do they get pushed to become a SMB, or being detected as a SMB, or they still decide that I want still to be considered as a startup?
So I think the official line is if they're over 10 years, they then move into SMB.
Hmm.
So there's a few requirements that I off the top of my head, I know that the 10 years is one thing. I also
Okay.
know that like if it's over like 1,000 employees, like employee size also matters. But if I'm being if I'm being completely if I'm being honest, like generally successful startups, a lot of them will kind of go straight into the kind of digital native businesses, or like independent software vendor team, or into enterprise. And then like if a startup's around for 10 years, generally then they're quite big. I think that's like the kind of nature
Yeah.
of it. So, look, we do see some transition, but generally, yeah, like it does depend. And also if a customer really gets on, we are customer obsessed, as we say. And I think that if a customer really wants to be in startup, but we're not going to be the people that say you have to come to SMB. So I think that's something that we make accommodations for sometimes too.
Get it. Yeah. Still, I could see customer obsession there too. So yeah, agree
Yeah.
on that. All right. I'll pick up one more question here, which is from Unni, and it is more on the enablement side. When you speak to a customer, do you see customer who are not aware of our services and they do not have an expert in their team? If yes, how do you build that conversation forward?
Yeah, I think it goes back to like it goes back to those four areas that I covered. So like data strengths to build on, key blockers, key projects to accelerate, scale, and think big. And they don't have to be AWS specific. So like
Hmm.
if they're don't have any cloud skills, like I just really want to understand, okay, what it could be from the smallest company to the biggest company, but what data are they collecting currently, and what are they doing there that we could potentially build on? The blockers. So if the blocker is that we don't have any AWS skills, well, we can work with the customer internally to potentially direct them to AWS trainings if that's something they're interested to do. Also hosting things like, once we have an understanding of where they are from a data perspective as well, I think we can also like align our SA to host like enablement sessions to understand a
Yeah.
bit more about that. So you know after that first call, we can then say, okay, this is where this customer's at. This is what they're doing. This is how AWS probably could apply to their business, and present back a sort of a pitch, so to speak, but it can be a technical sort of roadmap of what that business might look like on AWS. And then lastly, if they don't want to build that out, we have AWS partners. And that's really where our partner, when I say partner organization, these are kind of consultant, well, we have consulting partners and tech partners, but basically they allow our customers to to build out their AWS infrastructure from a hands-on perspective. And the brilliant thing about our partners is that this allows our customers to focus on building out and innovating for their own business, writing new code, doing new things, whereas a partner can focus on provisioning and managing their AWS infrastructure. So some customers going with a partner, if they don't see any value add in owning their own AWS infrastructure, having a partner there to allow them to focus on development and innovation is something that a lot of customers enjoy doing if they don't want to learn AWS.
Get it. In the interest of time, I'll take the last question. I know it's already Saturday and we are 11 minutes behind, 11 minutes ahead of it. So let me bring up the last question here. Give me a minute. Somehow my screen froze. So
Mhm.
hopefully it should be coming up
Ye-
now.
Yeah.
Do you see the question?
Yeah.
No.
Yeah.
So,
Well, yeah, I can see the question. Yeah.
okay.
So do big
Do big
companies like,
companies like Netflix with several AWS account have only one account manager?
yes, they only have one account manager, and I'm very jealous of them. No, but I think, um, but no,
Wow.
yeah, so they would only have one um, account manager, and they would have things like a technical account manager, and they'd have probably a few SAs kind of aligned to their teams. And I think the really interesting thing about businesses like that is that, you know, an account like Netflix is a whole business in itself. Like you've probably got several people who are like several talk tracks or teams working with Netflix on their database, and several talk tracks and teams working on AI. It's like another whole team working on innovation. So I think that with accounts like that, it's quite interesting because it's almost like a little separate AWS organization in themselves that are dedicated to supporting that large customer. So yeah, that like that, but that would be their only customer.
Great. That would be so much work, isn't it?
Yeah, yeah. Well, I'd sure like to. It would be pretty interesting working on it. I get all the insights and things about new shows coming up. But yeah, I think it'd be super cool. Like
Yeah,
just
yeah.
seeing all the technologies. If you ever are bored, like the Netflix case study is a super interesting one, and how they built on
Exactly.
AWS. Like all the things regarding kind of AIML and recommendation systems. And for me, that they were actually the accounts that I learned so much about, like, oh, this is how, Amazon Personalized is used in Netflix, and seeing what that sort of, how that technology is leveraged. And yeah, so really enjoy that.
Nice, that's great. Yeah, I would be jealous for them. Like they
Mhm.
would know more about how the next thing is coming up or what is the next coming up. So thank you for that, Jonathan. Yeah, it was a really interesting discussion, and we got to see the aspect of how account manager works in AWS. And thanks for being candid and answering all the questions. So I appreciate your time. Hopefully that it should have answered people's question also. If something is remaining unanswered, reach out to us and we may probably relay those questions to Jonathan. And if you enjoy the session, please show some love to Jonathan and Carl so that they will be feeling more motivated and find it more worthful of investing their Saturdays for something which is greater cause. So I'll add Carl also to stream, and I'll just thank you both of you for your time. It was interesting, lot of technical thing we discussed, lot of commercial aspect we discussed, and we hope this would have given you a little more insight on the technical aspect as well as the commercial aspect of AWS cloud. Thanks, Carl. Thanks, Jonathan. And if you have any resources which we can be sharing with customers, let us know, and we will put them on our resources page so that people can come back again and then revisit it. These will be recording would be available, and we would tag you in the recording so that if you want to share with your own network, feel free. Thank you so much. Have a good one, and we will be connecting next week. Thanks, Jonathan. Thanks, Carl.
Thanks, Ashish.
Thank you.
Carl, you want to say something? Jonathan, any last words? Anything you want to say? Not the last word in that sense, but yeah, means for the session.
Yeah, the only thing I wanted to just say, I'm not sure if everybody got the link to the actual white paper that my talk is based on. I just put that in there.
I'll share that on the resources section. Yeah, but that's amazing. Thank you.
Yeah. Just on my end, no. If anyone, always happy to have a chat. So if anyone wants to reach out on LinkedIn, feel free to do it as well. Just for me. Thank you.
Great. So have a nice weekend, everyone, including you, Carl and Jonathan, and we will connect back you again. Thank you so much. Thanks, everyone. If you like the broadcast, please show some love. Please like and maybe share with your network so that there would be more people getting benefited from this immensely useful session. Thank you. Have a good weekend.
Thank you.
Thank you.